This podcast supports fumigators in improving safety, compliance, and solutions. Always follow the federal fumigant label, state and local laws. Licensed fumigators are legally responsible for their applications. And now, on to all things fumigation. Out here, we don't just fight pests. We outsmart them. This is all things fumigation, where applied science meets real-world grit. I'm John B. Mueller, a fumigator by trade, and your guide to the science of fumigation done right. Each month, we saddle up with the people, the practices, and the precision it takes to keep facilities safe, compliant, and pest-free. Because when you're in the trenches of pest control, you don't need magic, you need science, and maybe a little cowboy spirit. Smarter solutions, safer practices, managed costs. Welcome to All Things Fumigation. All right, welcome to the next episode of All Things Fumigation. This is a special episode. It's our fifth episode. We're taking a break from the fumigation process, and we're going to visit with some fresh information on a new tool in our fumigation toolbox, in the IPM toolbox, that was just approved. And we're going to give some base information on this new product, Ethyl Formate. And we're going to interview a couple of people that will help fumigators like yourselves listening to better understand really the foundations of Ethyl Formate and how this product may evolve over the years like many products do. Despite what you hear about Ethyl Formate, keep in mind you never know where these tools can end up. I'll relate decades of being told that sulfuryl fluoride would not ever be used in a post-harvest format. And then in 2005, everything changed. So we'll get into this. We're calling this New Kid on the Block. I'm sure I'm going to get a lot of grief over the picture of New Kids on the Block. If you're watching, if you're listening, you've been spared. So we're gonna focus on Ethyl Formate, and this episode is being sponsored by the Fumigation Company. This is my company. We're a consultant to and source material expert to commodity companies, food processors, fumigation companies. We focus also on product innovation, product representation, really to look at solutions and improvements to fumigation processes. We're a training company, and we also have digital solutions that focus on transparency of both the service and the management of fumigation, all gathered and bundled to try to focus on delivering greater value with the fumigation tool. You can visit us. We have a library of podcasts. You can either search us with All Things Fumigation on your favorite streaming option. You can also go to www.thefumco.com, and we also have a section there, a library of our podcasts. In this episode around Ethyl Formate, we're going to talk about EPA's recent approval. I think it was signed actually September 2nd. And for allowing Efume, which is the brand name for a fumigant, which is Ethyl Formate, and the approval was for a post-harvest application and use in the United States. Now, there's more processes that will have to take place. They'll have to get state approvals, and there's other approvals with USDA, APHIS, and some others that are underway now. But this is the first step in really a long journey, and we'll learn more about that. Again, the brand name Efume is trademarked. It's truly a new post-harvest fumigant, and it's really the first one in 69 years. Now, in that period of time, that statement seems odd, we've had a lot of other labels that have come into play, but they were for the same molecule, right? So metal phosphides, we originally had aluminum phosphide, that then became some labels with magnesium phosphide, then cylinderized phosphine products. they all kind of morphed with different packaging for the same molecule. Then you also think about sulfuryl fluoride, like we just mentioned, going from Vicane to Profume, which is a post-harvest fumigant. So again, all old molecules. Now, is ethyl formate new? And as I did a deep dive into looking at ethyl formate, one of the things I learned was ethyl formate was a fumigant in the U.S. I think it was approved in the 50s. It was actively used in California on raisins in the 1970s. And then it fell off like many fumigants, of the past did, liquid fumigants and some of the others. Don't really know much about that. We are going to interview a researcher, and maybe we'll find out a little bit more about that. But, that this product's been brought back into the fold. And initially, it's really being focused on as methyl bromide replacement in perishables, so some of the fruit that's being imported or exported out of the U.S. Now, what is ethyl formate? And for those of you who are viewing, even if you're not, what do ants and rum and raspberries have in common with ethyl formate? It's very interesting. Ethyl formate is formed when alcohol reacts and becomes present with formic acid. Formic acid is what ants produce, some ants produce as a defense mechanism. Again, alcohol reacts with formic acid. It creates an ester, and that becomes ethyl formate. It smells like rum. The label actually states a fruity rum, so I guess a rum cocktail. And then it's responsible for the flavor of raspberries, which happens to be my favorite fruit. And it occurs naturally in plant oils, fruits, and juices. And when you look at the formula, I'll read it off. It's HCOOCH2, C small h3. That's a massive molecule. So when we start to think about how strategically this gas can be used, this is an important feature, right? Number one, it's got a carbon attachment, so it's an organic compound. And the other fumigants that we have on the market that we use today, phosphine and sulfuryl fluoride, are inorganic compounds. So inorganic compounds tend to not bind up with other organics. They move through the interstitial space freely. They can translocate, they can get to the pests and eliminate the pests. Methyl bromide is the tool that we've got that is an organic compound, and it does tend to get bound up. And so that's something we can expect with ethyl formate, and we'll look at it a little more deeply here. And obviously, application processes will adjust for a feature like this. So continuing with how ethyl formate is packaged. So it is a gas. It's contained in a cylinder. It's a premix. We're going to talk about this a couple of times, but ethyl formate is flammable. The premix, a cylinderized premix, is 16.7% ethyl formate, and the balance is other ingredients, which is predominantly carbon dioxide, so 83.3% carbon dioxide or other ingredients. Unlike the premix of Efume, which is phosphine and carbon dioxide in a non-flammable format, it's my understanding that this is a flammable mixture, and we'll get into how it's managed and applied here. So the boiling point of ethyl formate, and this is where we really start to separate from some of the other fumigants in likeness, is 129.2 degrees Fahrenheit. This liquid in the cylinder does not change phase of matter until it hits 129.2 degrees Fahrenheit. That is a very high temperature compared to what we're used to. So this means that it requires a volatilizer to change that phase of matter, and so that it can become a usable gas for you. Now, looking at the other fumigants, SF changes phase of matter, turns to a gas at negative 67. Methyl bromide was a higher one at 38.4 degrees Fahrenheit, which is really historically where we get that bottom fumigation temperature zone of 40 degrees Fahrenheit, and not to go below for most fumigants. And carbon dioxide is negative 109 degrees Fahrenheit. So at 129 F, that's pretty warm, right? That's going to take a lot of energy to convert. Take a look at solubility in water. This has a behavioral impact in how a fumigant is used. We're generally not used to solubility with some of the fumigants that we have. And the solubility of ethyl formate is 9%. Now that's considered freely soluble. It's not highly soluble. Methyl bromide has a lower solubility rating of 1.75%, which lends it to be slightly soluble in water. But with free solubility, this is a consideration. Any moist product that we're fumigating can be taken up by ethyl formate, anything with a moisture content. Much of what post-harvest people are treating have very low moisture contents. But again, keep in mind, we're targeting, in the beginning at least, with ethyl formate, the manufacturers are looking at perishables, so grapes and some of the fruit primarily being imported. So we look at vapor pressure too. There are 200 millimeters of mercury as a vapor pressure for ethyl formate. Not to bore you, but this is extremely important as a fumigator when we're applying fumigant. Vapor pressure is important because it determines how quickly the gases equilibrate as we apply them. We want a good balance. We want an equilibrium in these spaces that we're treating. And at 200 millimeters of mercury, this is a very heavy gas. It's a very low vapor pressure, heavy gas. It's going to be very slow to equilibrate versus the fumigants that we're used to. And this is an important point to think about and observe how the label will address management of this heavy gas. We also look at the LEL or the explosive limits of some of the fumigants that we use. Many of them are not explosive or flammable. A couple of them are, phosphine and now ethyl formate. Ethyl formate has explosive limits between 2.8 and 16% by volume. So, compared to phosphine, which is a lower LEL at 1.79% by volume. So, is something, again, we have to watch and manage, and the label will do exactly that. From a human health effects perspective, ethyl formate can irritate eyes, skin, mucous membranes, and the respiratory system. It is a central nervous system depressant, definitely a focus, and this information can be found on SDSs associated with ethyl formate. And then from a respiratory protection standpoint, we want to look at personal exposure levels, and this is where it really starts to separate again. The PEL for ethyl formate, for Efume, is 100 ppm. So 100 parts per million, we're not used to those levels. We're used to thinking about 0.3 ppm for phosphine and 1 ppm for sulfuryl fluoride. So 100 ppm is a bit of a turn. The IDLH, or immediate danger to life and health, is 1,500 ppm. And all these are important safety factors as we as applicators look at approaching something that's new and managing that change safely and effectively. Oddly enough, and I still can't get my mind around this fully and how this will impact our applications, but U.S. FDA recognizes ethyl formate as GRAS, or generally regarded as safe. This does play out in the label a little bit later on, and we'll kind of guide to that here. And this is really it. EPA signal word for most fumigants is danger, right? So danger is the highest risk level. Ethyl formate, according to the current label, is showing a caution label. So that's has to do, I would imagine, with some things that we're going to learn from one of the people we'll interview here shortly. but also from, just from the GRAS rating and generally regarded as safe. But I will caution, any gas that can be ingested, can be breathed in, has to be respected. And just because it carries a caution label does not mean that we should be handling this type of gas any differently than the others from a safety and caution perspective. And then the last item I want to cover from a base perspective on ethyl formate is who makes Efume. And Dreslavka is a global chemical manufacturer based in the Czech Republic. I've worked with them a little bit here in the last few years. Very capable group. They have a sister company that really carries these agricultural products called Intresso Group. And towards the end of the podcast, we'll be interviewing Cade McConville and asking him a few more questions about operations and marketing of Efume. All right, this is exciting. My first interview on All Things Fumigation podcast is with a good friend of mine, Dr. Spencer Walsh. Dr. Walsh is a post-harvest researcher and adjunct professor at UC Davis. And Spencer has done a tremendous amount of work with post-harvest fumigants. He's working globally with over 40 registrants with registrants and over 40 commodity groups, trade groups, and plays a really critical role for us in negotiating with import and export conditions for a lot of the commodities we work with. So I'm very excited to have Spencer. Spencer's a good friend. He's got a beautiful family, 3 daughters, and a very supportive, wonderful wife, Jessie. And a little background on Spencer: he's a very good skier. And the only weakness I found in Spencer is he's very poor at darts. And I encourage anyone to challenge Spencer playing darts. It's a little fun dig there. But very, very, very much appreciate you joining the podcast. And thank you for being here.
Well, thanks for the invitation, John.
Yeah, appreciate it. I want to, obviously, like you and I have talked about, is we're focusing on ethyl formate in this episode. This is kind of a special episode for us. And being that you've been working with ethyl formate for quite a while, we want to try to glean as much information from you as we can on the basics of this new fumigant, this new tool. And again, try to put this together and start to evaluate how this will roll out in a post-harvest toolbox. So, first things first, I guess, how long has Efume or ethyl formate been researched?
Wow. As part of kind of supporting its regulatory package, we've had to dig back in the literature. I think the first thing I've found was in 1902, found some more work in the 1930s. Now, most of those are related to, let's say, occupational assessments associated with its use as a food and a flavorant. But really, its use as a fumigant started in, say, the 50s, and then was even registered by the USDA. This was predated US EPA FIFA registrations in the 50s, and then in the 70s, it's actually had an active registration in California, was reused on dried fruit. And for whatever reason, much to our disappointment, that registration was not renewed. And so we've kind of had to start all over from square one in the last 5 years or so.
That was a shocker to me. I knew that CSIRO out of Australia had kind of pulled this out of some mothballs, so to speak, but I did not realize that it had been used in the U.S. prior to this. So that's interesting information. As you've worked with this, how does ethyl formate compare to conventional fumigants today? I mean, can you give us some insight on that?
Well, I think that its use historically, or at least I'll talk about the use in California on dried fruit, was one that really took advantage of its use as a liquid. The liquid was applied; it would fume under tarp, And then kind of phosphine came onto the scene, and I think largely took over that role. It works fairly well on lepidopteran, on your stored product pests, but I think it's important to point out that I've never seen a material that is more efficacious towards mites and more efficacious at low doses to a lot of the external feeders. At least we're worried about the fresh fruit industry in California, your thrips and your scale, psyllids, et cetera. Highly effective on those pests. I think that's a really unique feature of it. Of course, all fumigants have their own unique chemistry, and I hope I get a chance to talk a little bit about how we're really harnessing the unique chemistry of ethyl formate in these latest applications towards fresh fruit. If someone's familiar with using propylene oxide, I think it's worth noting that it's of comparable physical chemical characteristics as far as vapor pressure requiring to be propelled, heated during application as such. So, there are some commonalities, but all fumigants are unique. And I think from a toxicological perspective, looking at mites and some of the kind of small surface feeders is highly effective.
Well, since we lost domestically methyl bromide, we really haven't had an extremely effective tool on mites. So that's a good thing, right? That we've got a
Oh yeah.
we're expanding our reach here. Does that also, in your mind, translate into SOCID impact as well, you think?
I have not tested it on SOSIDs, but somebody needs to do that very quickly because I think it would. My hunch would be it would directly transfer. Yes.
Yeah, as a surface pest. Yeah, yeah, that'd be interesting. So, from you are a PhD chemist, Spencer, and help us understand. I mean, this molecule looks extremely dynamic and very different than what we look at. What is the makeup of this new molecule tell us from a PhD chemist perspective?
Well, I think the first thing, if I was describing how we're using this chemistry, is that we're 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 executing an esterification of the active ingredient. The AI, the toxic agent, so to speak, is formic acid. Formic acid, though, really doesn't want to behave like a gas. So we needed a way to make formic acid behave more like a gas. We really have two choices. We can either methylate it or we can ethylate it. And I don't know the history of why they chose ethyl over methyl, but it probably has to do with cost and consumability, right? I mean, we don't want methanol in our foodstuffs, but personally, ethanol is one of my favorite molecules, and I consume it regularly.
I think many of us do. So, well, good insight. Now, it's my understanding, because this is an organic compound, it's going to be taken up pretty quickly. Can you give us a little bit of information on what to expect from a performance standpoint and sorption and things like that?
Sure, I'll preface this insight with, the what I'm most heavily involved in, and that's fresh fruit and bringing this to commercialization as fresh fruit alternative to methyl bromide. And I think it's really important to make a clear distinction between this work in fresh fruit and work on durables, more your grains, your tree nuts, dried fruit, etc., low moisture content commodities. And that's because when you're treating fresh fruit, you have an opportunity to break that ester link into the formic acid, into the ethanol, simply by taking advantage of the water-filled commodity that you're using. And so our applications of ethyl formate know, understand, appreciate, I would say, and even exploit the reaction of this molecule with the water-filled fresh fruit. And what that really enables us to do is create levels of ethyl formate in the enclosure at the end of fumigation that approach meet and by design are lower than the reentry thresholds per prescribed by the US EPA label. So with the fresh fruit, we're really taking advantage of this hydrolysis chemistry and this potential for absorption. When it comes to the durables, you're clearly not going to see the same type of hydrolysis. And so it's going to be different behavior altogether. And I think a lot of that research needs to be conducted to better understand the expectation on the durables. Review of the literature, of course, will get you back to some uses right now on grain in Australia, but I'm not as familiar with those particular uses and can't provide too much insight on the rates of absorption.
Yeah, and we discussed that too. We see what the label is today. We fully expect that to be broadened over time, and it could go quick. It could take a while. We're not sure. So more chapters in this book. One of the things with such a large molecule that I've asked you before is there are fumigants that are particularly effective on adult stages. There are fumigants that are less effective on the egg stage, which is really the proof of an effective gas fumigant tool. With this large molecule, can ethyl formate get into the eggs of beetles and other insects into that aeropile? Do you think that there'll be challenges with this molecule?
No, I mean, as far as its size relative to other fumigants impeding its ability to get into these respiratory structures, I have all the confidence that difference in size is not going to factor into an inability to access where it needs to get. Typically, the respiratory openings on insect eggs and other life stages are large enough to allow thousands of molecules through simultaneously. And I'd also comment that with formic acid essentially being linked to the toxicological mode of action, ethyl formate is getting carried in through these respiratory openings, then being hydrolyzed, and that's actually how it works. So the fact that we're finding mortality in insects is evidence enough that it is penetrating in through those respiratory openings on eggs and all other life stages.
That's important and promising. So yeah, thanks for the insight. So you've covered this a little bit, but I guess in a very layman's term, the mode of action in killing insects would be described as you mentioned it's hydrolyzed. Is there any more information, I guess, from more of a basic description?
Sure. So in my classes, how I like to teach the mode of action of the fumigants is by categorizing it into two main mechanisms. We have 5 or 6 key toxicants, fumigants, that work by actually reacting with biomaterial. So methyl bromide methylates it. Any nitrogens and sulfurs, or really any type of nucleophile in the biomolecule, will be methylated. Propylene oxide, of course, another alkylating agent, would propylate. Sulfuryl fluoride would hydrolyze into fluoride, and that is usually initiated by a biomolecule, nucleophile in a biomolecule driving that chemistry. Ethyl formate's much the same. So that hydrolysis reaction, after it gets into an organism, is going to be initiated by a biomolecule and release formic acid, and then go on to impact the various physiological processes that formic acid is known to influence, chiefly cytochrome P450 pathways. We also have a couple of non-reactive fumigants who are actually like electrochemical reductants who disrupt electron transport and flow in many types of processes. What comes to mind immediately would be phosphine. Phosphine is the most reduced form of phosphorus, and its presence in any type of electrical activity within an organism is going to be disruptive. So you've got reactive and non-reactive, and certainly ethyl formate, which we're talking about right now, is a reactive fumigant.
Perfect. Perfect. Thank you. Um, what about from your perspective, strengths and weaknesses, in managing this gas? Is there any, as you've handled this in the laboratory and actually out even in some limited commercial testing in the field, what advice, what's from your view in working with all these fumigants, what are the strengths and weaknesses that you see from an operational standpoint?
Well, I'll break this question, if you don't mind, into two halves. I'll talk about operational and then maybe some technical, some technical input on limitations, strengths, and weaknesses. So operationally, this molecule is like a dream come true from a fumigator's perspective. It can be applied with a relatively inexpensive volatilizer if you're applying the premixed carbon dioxide dilution. Or if you have a dynamic blender, it could be applied by mixing on site. There'll be labels to support both application techniques. And out in the field, that just requires a generator. So it's really a portable fumigation process. And that's wonderful, because one of the applications we're pursuing in California, which I think will be adopted by many fresh fruit types and also globally, is taking this fumigant to the field to treat bulk fruit right after harvest. There's some really important advantages of that. First, the fruit, which is being staged for basically shipment back to the pack house, is warm, and it doesn't even know that it's been picked. I mean, fruit is alive. It does not yet physiologically understand that it is no longer on the tree. So it's relatively warm at ambient field temperature. And it also means that the insects are at ambient field temperature. And as we know, anytime we get an opportunity to treat an insect at warm temperatures, we're going to do better than if we're trying to treat it after it's been chilled during the cooling process. This is particularly important for mites. So getting a chance to get after the mites while they're warm in the field is really, really, really advantageous. So from that perspective, the operational ease associated with this molecule has transferred into a new opportunity to get at the insect pests out in the field before they're put back to the packing house and are cooled, which makes our lives really, really easier. Many of the regulators, both federal and at state levels, are really keen on this, because this opportunity to treat and basically disinfest surface pests from the fruit post-harvest eliminates the opportunity to go out and have workers actually interact and pick fruit that had recently been treated with foliar insecticides in an attempt to bring in clean product into the packing house. So I think that it's a real efficient use of pesticide, and it really is in line with a lot of the consumer and regulatory demands that we're seeing right now. Now, that being said, it does have some technical limitations, and that is, of course, since we're using the hydrolysis chemistry to scrub essentially the ethyl formate during the course of the treatment, it really is not very effective on internal feeders, particularly fruit fly larvae, because quite frankly, the ethyl formate has broken down into the ethanol and the formic acid, which are naturally occurring in the fruit, but therefore not available to get into the respiratory openings of the to larvae to actually go to work. So there was one technical limitation. I would say it would be targeting the internal feeding fruit fly larvae. And there's a reason why targeting those fruit flies is so difficult and is really the grand challenge of fumigation. So the work continues towards that end.
Great. So you've answered a couple other questions that we have ahead. So you said that the most impacted insect is surface insects and mites, but any of the internal feeders are the challenge for ethyl formate. What about MRLs? You talked to me a lot about over the years about MRLs and managing those. What do the MRLs look like? This acronym, if I misspeak, correct me, Spencer, but it's is it maximum residue levels, right? Do I get a name?
Yep, correct.
All right.
Yep.
So what are the MRLs for ethyl formate?
Right. So these maximum residue levels really are really important for international trade. And of course, the U.S.'s fresh fruit industry, particularly that in California, Oregon, and Washington, really depends on export market access. And what the MRL is an indication of is whether or not the fumigate or pesticide label was followed correctly. It's often misinterpreted as a safety threshold, and an exceedance of an MRL on a fruit would make that a fruit in some way, shape, or form unhealthy. That's not the case. It's actually to ensure that the farmers, the growers, and the applicators are doing what they need to do per labeled instructions. With the case of ethyl formate, I got to admit, it's almost another one of these dream come trues because ethyl formate itself, ethanol and formic acid are naturally occurring in the fruit. It made it very, very, very difficult to detect the levels that were formed as the result of the ethyl formate fumigation. In fact, we had to go into the chemistry lab and make what we called mass labeled ethyl formate, where we tag elements in the molecule, atoms, carbon, hydrogen, etc. And then we fumigated with the mass labeled ethyl formate. And that slight mass difference is something we can pick up with our analytical instrumentation. And that's how we were able to quantify the ethanol and the formic acid that resulted from the ethyl formate fumigation. The US EPA and the respective states see this information, interpret it, and we're still pending California's registration and decision, but very, very notably, the US EPA has registered or has come up with an exemption from food tolerances for ethyl formate. So that clearly reflects the safe nature of this molecule as far as foodstuff residues are concerned. The US EPA's interpretation of an exemption from tolerance is usually reflected in other countries' interpretations. So while not every country has tolerances in place for ethanol and formic acid per se right now, we expect no problem. And really, the difficulty associated with detecting these residues over the background natural levels should provide, an adequate scenario, and we expect no difficulties with the MRLs.
So it looks like ethyl formate is going to be exempt from these tolerances, which is pretty amazing, really.
Pretty amazing. It's what I like to say is that this molecule satisfies quite a few consumer and regulatory demands. Consumers, they don't want residues, and the regulators who reflect that consumer opinion, they respect and appreciate that. And with this particular molecule, they also recognize that us using the fruit to essentially reduce emissions post fumigation is an excellent way to mitigate against the public's desire to minimize exposures to these toxic gases when and all possible.
Which makes this really a residue-free treatment, which is, like you said, what the consumer wants. They don't want insects and they don't want pesticide residues, and with this, they get both. So that's pretty key,
Yep.
don't you think? Yeah. So look, I've got one more question. Really, is what advice do you have for fumigators? What should they know about this Efume, this ethyl formate, as it starts to come into the market? What should they start mentally preparing themselves for, from your perspective?
John, you and I have shared our appreciation for ethanol together and had many discussions about the need to monitor your fumigation. And if there's one important message with ethyl formate, you have got to monitor the fumigation. The concentration And knowing what it is going to dictate, of course, not only the respiratory protection that's going to be required, but when you're allowed to go and break the fumigation down. And I'm hoping that this is going to be a tool to familiarize more fumigators with this importance, because what we've done is essentially take that appreciation and understanding absorption, which you can really only grasp if you're watching the concentration, and turned it into a fumigant that's going to satisfy the demands for food safety, food security, and then all of the consumer and regulatory issues that we have to address.
Yeah, I mean, monitoring is key. It's not a single function; it's a continuous process. So, I'm glad you brought that up. I think also too, a concern of mine is, and I want to get your perspective on this as we wrap up, is, there are some safety enhancements from a residue standpoint, and just many aspects of this fumigant. But it's still something that, from a human health standpoint, has to be respected. Correct?
Oh, absolutely. Yes. Yeah. I would never say that, hey, this is a safe fumigant. A safe fumigant is an oxymoron, right? You have to respect and appreciate every molecule, particularly volatile organics like ethyl formate, that, over 5 to 15% by volume in air are always going to be flammable. They need to be appreciated, respected. Labels need to be followed. And although this is relatively safe, it still is hazardous, and that hazard needs to be managed to minimize the risk.
Perfect way to end an interview with you. Thank you for the insight on this. Thank you for joining us today. I really appreciated this. I've been looking forward to this since I started All Things Fumigation podcast. I wanted to get you on here, and I hope I can get you on here again. You've got a lot to offer our industry, and we're very grateful for you, Spencer. Thank you.
Thank you, John. It was my pleasure.
So Dr. Walsh gave us a tremendous amount to think about in terms of the foundations of this new fumigant, this new tool. And, this has really turned into a very large amount of information, so much so that I think we're going to split this podcast into two. And we're going to interview Cade McConville from Entresso Group and Dreslavka in the next episode of All Things Fumigation. And we're going to dig a little deeper into the manufacturer's history and perspective, safety regulations, and some really exciting outlooks with this product beyond some of the early labeling. I want to remind everybody, be a science cowboy, apply the science, and protect your product. You heard a tremendous amount of information from Spencer. Fumigants are applied science. Everything behind these labels are science-based. They're not magic beans. We have to be very diligent about our process, our safety, our effectiveness, and it is critically important. And I want to take a moment to ask you to hit like on your streaming choice right now. This is very important to us. This is one of the reasons we do it, and it does help us a lot. So if you liked what you heard, give us a like. We would greatly appreciate it. And then we want your feedback. I know we say that a lot, but we mean it very intensely. We want that feedback to help mold what programming will be in the coming episodes. And then I also want everybody to understand, from a disclaimer standpoint, this podcast supports fumigators in improving safety, compliance, and solutions. Always follow the federal fumigant label, state and local laws, and licensed fumigators are legally responsible for their applications. I want to thank you very much. Appreciate it.